Hello, my name is Byung-Chul Yoon, and I will be presenting today. Topic of today presentation is part one of communication theory. I'll be covering various aspects of communication theory. s- Sorry, throughout this session, communication theory is a core course of the electronic engineering major and is quite a challenging subject. Therefore, I kindly ask for your understanding if some parts are difficult for this outside of this field. The table of contents will proceed in the following order: type of signals, uh, commonly used signals, convolution, and correlation. First, I will explain the type of signals. Signals can be categor- cat- categorized as analog, digital, continuous, and discrete. Uh, A represented on analog continuous signal, and B is digital continuous signal, and C is analog discrete signal, and D is digital discrete signal. Next is the periodic signal. A periodic signal refers to a waveform signal that repeats at a constant period. Such a signal has a period t and has the characteristic of maintaining the same value after a specific time interval t. Uh, the equation for a periodic function can be expressed as shown in the formula on the PPT. Next are energy signals and power signals. This type of signals frequently appear in communication studies, but for now we will move on without developing deeper. Sorry, without delving deeper. Next is on combination function. The function displayed on the session is the unit step function. Unit step function has a value of 0 until it reaches 0 and then take a value of the one from that point onward. Mm, Next is impulse function. The impulse function is a very unique function. Each characterized by the x-axis approaching zero and the y-axis driving to infinity, resulting in a inter- integer with an area of 1. Due to its unique properties, the impulse function is one of the most commonly used functions. Next are the sine and cosine function. Since this is a well-known topic, we will very, very briefly view the illustration and move on. Uh, Next is exponential function. The exponential function is introduced on this page is one where both C and S are real numbers. As this familiar function, we will just review the illustration and proceed. Next is exponential function, where C is real number and S is purely imaginary number. This unique represent a periodic function with period t equal uh, to phi over omega zero. And the graph of this function is represented in the complex plane where the real part form a circle with a radius of and imaginary part forms. The equation below is the transformed form using Euler's formula. Next is exponential function when both c and s are imaginary numbers. Since the equation is complex in the case, we will simply note its existence and move on. Next is rectangle function. As the name suggests, it has a square-like shape. Unique Uniquely, this function can be expressed as the difference between two step functions. Next is triangle wave function. This function has a triangular shape, and please note that such function exists and we'll move on it. Next is sampling function. Uh, the equation for the sampling function is shown on the PPT. This function has maximum value at t equals 0 and oscillated while decreasing to the left and right. The sampling function is typically represented using the sinc function. Next is convolution. Convolution is an important operation used in various fields, including signal processing, control systems, imaging processing, and probability theory to model the interaction between two functions. Um, the illustration below shows how the values result from the convolution of two factors. Convolution is widely used in various fields such as signal processing and image signal processing and AI, as shown the illustration. Next, next is correlation. Correlation has two types. One is autocorrelation, and another is cross correlation. Autocorrelation is compare a signal with itself, and cross correlation, which compares one function with another. The equal for each are shown on the PPT. Autocorrelation, as you mentioned it earlier, is a method to measure how similar a single is to itself over time. It is useful for analyzing per- periodically and noise pattern. Cross correlation, on the other hand, measure measures the similarity between two different signals and is useful for determining if the signals share similar pattern and for identifying the time delay between them. The graph above represented autocorrelation, which graph below shows down cross correlation. 아, 그렇지만 바로 멈춰주시면